Hello everyone. In this video we're going to take a look at subtracting fractions. So the way to look at subtracting fractions is very similar to the way we look at adding fractions. We look at the numerators and we do the operation with the numerators. The denominators, in this case the denominator is quarters, 4, okay, stays the same because that's what we're measuring our pieces with. These are quarters, that's the type of pieces we're using. So if you want to look at it visually, here I have 3/4 right here. 1, 2, 3/4 pieces that if I put together would give me 3/4 of a circle, but I am going to delete one. And after I delete one, we find that I have 1, 2 remaining. 3 take away 1 equals 2/4. Okay? Often you'll have two fractions where the denominators are not the same and you're trying to do an operation between them. And a lot like when you're trying to add and subtract different measurement units, you can't do it until you standardize them both and make them the same. When we're doing that in fractions, we call that finding a common denominator. Here we have two different denominators. We need to find a number that's common between them. This particular one is really easy because I need to take 5 and make it match to 10. And fortunately, it does match to 10 because 10 is a multiple of 5. So I know that if I do 5 times 2, that will give me 10. And so what that equals, it means I'll have a fraction over 10 subtract another fraction over 10, in this case 2/10. But since I've multiplied the bottom, if I want to keep my fraction at the same value, then I have to also multiply the top in the same way. So 3 times 2 is 6. So I've exchanged this fraction, 3/5, to this fraction, 6/10. And if you're wondering how can Mr. McPherson get away with just changing it, hopefully by now you realize that with fractions, it's about what the overall value is. And if you took a calculator and did 3 divided by 5 and 6 divided by 10, you'll actually get the exact same answer, which in this case is 0.6. So I've set up a question now that's very similar and worth the same as my original, 6/10 minus 2/10. And now the subtraction becomes easy. I simply am going to get an answer that's still in tenths. And I'm going to do 6 minus 2, which is 4. Okay, and my answer is going to be 4/10. Later we'll talk about simplifying that further, but for now, that's the answer we're going to stick with. So that last one was relatively easy, but in this case, I have two different denominators, 8 and 3. Neither one of them matches up with the other exactly. So I can't multiply 3 to get to 8, and I can't multiply 8 to get to 3. So now I have to find a common multiple of those two numbers. And if you guys remember way back in September in chapter 1, that was one of the first things we did. What we did is we did just 2 rows of numbers, rows of multiples of 8 and rows of multiples of 3. So we might do 8, 16, 24, and then we would do 3, 6, 9, and I won't carry it all out, but the first multiple between the two is when we would hit 24, which is also a multiple of 3. So then we have 24 as a common multiple. So that's what we're going to work towards. We're going to work towards 24ths to get started here. So that means my new fraction is going to be over 24. But then the question is going to be, what are the numerators going to look like? So to get 8 to 24, I had to multiply it by 3. So I can do that with 7 as well, and 7 times 3 is 21. And to get 3 to 24, I have to multiply it by 8. And so I'm going to do that with the numerator as well. 2 times 8 is 16. And so that set up a relatively easy subtraction question, 21 minus 16, which is 5. And over the bottom, it's really crucial. I've already seen people adding these together when we're looking at adding fractions. We do not add them together. We do not subtract them. They are like our measurement unit, so it's still going to be 5 over 24. Okay? Just one more example, because it's really more of the same. I wanted to give you a fraction that had a improper fraction, so where the numerator is larger than the denominator, not because you have to do any special tricks, but actually just because you should know that that's exactly the same. We do the exact same process. Nothing changes. So I need to find a common denominator between 2 and 5. And without doing the rows and everything, I hope you know by now that a common multiple between those two is 10. So I'm going to rewrite my fraction as multiples of 10. my equation, I should say, as multiples of 10. Okay, denominators of 10 for my fraction. And how did I have to get there? Well, I had to do 2 times 5 to get there. So that also means I'm going to do 12 times 5. And that's going to be 60. And 5 times 2 gets me to 10. So I'm also going to have to do 2 times 2, which is going to be 4. And I wind up with the fraction 56 over 10. And of course, this is an improper fraction, and I can not only simplify this a great deal, but I can also turn it into a mixed number, which we'll talk about a little bit later. But that's the standard answer for right now. I've done my subtraction. This is the final value. Okay, so please remember, don't mess around with the denominators, don't add them, don't subtract them, don't do anything different to them. They stay the same throughout the question once I've set up that common denominator.